Hello, Cardinals. We're going to talk about Investigation 8.1, which is investigating storm surge. And our essential question is, how do storm surges impact land? Just want to review a few things from previous lessons talking about hurricanes. In order for a hurricane to form, they need to form within 311 miles of the equator, and that's where Coriolis effects begin to deflect the wind and cause them to spin. The warm water must be at least 80 degrees and 50 meters deep of that warm water. It takes a cold upper atmosphere and a still ocean. And that map to the bottom just shows you where hurricanes form and how they move. Introduction today, we're going to be talking about storm surges and creating models to keep track of the behavior and power of those hurricanes. And we're going to be analyzing and interpreting some data, including wind speed, longitude, latitude, and then making predictions about hurricanes. Some background knowledge for 8-1. The most dangerous part of a hurricane is the storm surge, and that's the water that gets pushed up from the body of water or a nearby lake or the ocean. And the low pressure at the center of the hurricane actually draws water up into a hill, and then it causes it to grow even taller. This surge moves quickly across the ocean and causes flooding when it contacts the shorelines. We're going to be investigating that today. So as we look to this, we're going to be recording our information. We're going to be doing 2A, B, and C to start our lab, talking about the most important factors when determining storm surge. And then B, you're going to be writing, I think that a blank will be most vulnerable to flooding because you'll be choosing between a gentle sloping beach or high cliffs. And then we're going to be using our equipment to investigate this question. We have modeling clay, we have a clear tray, and then we have some skewers with labels on them. So this should be done for you already, but we're going to have two different types of landforms, a steep cliff and a gentle slope. And we're going to be, that should all be done for you, having the clay 100% set up. And you're going to use a permanent marker. This should also be done for you to mark the skewers so you can measure how deep the water gets at the different levels. Me pouring your water in the tray, and then you have a sheet that's going to keep track of how high the water went for each different test. All right, you got storm surge data, you got non-hurricane, this is before you start, and then hurricane conditions, you'll be blowing through a straw, and then keeping track of how high the storm surge is in centimeters, and then averaging those. After a while, you'll flip-flop items, and then you'll model a change in water levels during a hurricane. You're going to add more water. So you're going to add another 0.5 centimeter of water, and then you'll model the hurricane as the winds push towards the storm surge. So each person has a different role. One person's going to use the straw to create wind. Somebody else is somebody else can be observing the water, and then use the ruler to measure how far the storm surge floods inland, and someone else to record the observations. You discuss how far inland the water went, if the hurricane conditions were correct, and how high the storm surge was when it hit the coastline. Then you'll be switching. We're not reshaping, but you're going to switch and then test the opposite landform. Repeat the steps, and then we'll be talking about this in class tomorrow. So summary. A storm surge is usually a high water level caused by low pressure and high winds. Gentle sloping landforms are more vulnerable, you'll find this out today, to flooding from a storm surge. Steep cliffs are less vulnerable. Here's a little picture to review. More information about hurricanes, and then information. So that's what we're doing today, Investigation 8.1. If you have any questions, please contact